one question that was asked, is this a project or what is it? It's a product. Bugs and I moved to Hong Kong, and over the last 4 years started a company. We have people who work for us, and about 700 of these machines have been sold and so far. So the question first is, why make an espresso machine at all? And then the secondly is, why have a tablet? And the reason is simply that making good espresso is quite difficult for two reasons. One is there's a lack of feedback when you're making it. It's a pressurized vessel and you don't really know what's going on. And secondly, there's a lack of control as to what you even might be able to do if you had control over it. And traditional machines will tell you the temperature and the pressure, but both are actually lies. They're not real measurements. So one of the problems is they give you a pressure reading, but it's the pump. Whereas espresso is made by putting water into coffee. The coffee resists the water, creates pressure. And what you really want to know is the pressure that is at the coffee, so that if the water is spurting through, your pressure is very low and you're not extracting oils, you're making bad coffee. Or if your puck is much too fine, your pressure maybe has gone up to here and you're just extracting essentially mayonnaise out of your coffee. So traditional machines don't show you the real number. And secondly, traditional machines, the technology goes back essentially 100 years, and the stability of heat is achieved through masses of metal. So this is all stainless steel. This is a huge stainless steel thing. There's a boiler back here. And the water temperature is set in here, but by the time it goes through this exposed piece of metal, it drops something like 14 centigrade. But I say something like, because your first espresso of the day might be 25 centigrade, because this is still cold. But if you're a cafe, you might only drop 4 centigrade because you're putting so much hot water through here. So this thing here is varying hugely. And the usual Italian hack for this is before they make their coffee, they just turn it on. Steam comes out, and when the steam stops, they make coffee. So they know that that's now under 100, but close to it. That's very imprecise. So the usual way to measure the temperature is to make this what's called a portafilter. That's the part that locks in here. And you put a temperature bead on it and a pressure sensor. And you find when you measure it that these temperatures, this is unfortunately in Fahrenheit, have this variation that happens because the hot water is going in and then it gets affected by the metal. Also, even this test device is all stainless and lies quite a bit. If you use a fast probe, you get very different results. This is 5 seconds in from even the test instruments. So the problem is we don't even have data to know what's going on when you're making coffee. When espresso was first invented, before these things existed, these existed. And this was just a tank of boiling water and a lever that you would pull, and you'd have a pressure gauge which was measuring the actual pressure of your muscle. And with this, you could vary the amount of muscle force to dynamically change the pressure. Okay? You didn't really have a good idea of the temperature, but you did have real control in real time over pressure. And lever machines are very much not dead. This is a Hungarian that modifies these. He's put a Bluetooth pressure transducer and a digital Bluetooth scale and charts what he can out of what's going on. Okay? So in order to revisit coffee, or espresso I should say, we first made a prototype. So I went to Seattle, which is all the coffee engineers in the world are either in Italy or Seattle. So I go to Seattle and I hire somebody who's got a hardware software background, and we make from CNC an instrumentable coffee machine, right, on a piece of plywood. This is the standard test equipment, but inside here we put our probes as close as possible to the coffee itself. And if you run this thing for about 10 minutes, the stainless steel finally reaches equilibrium, and then you can calibrate this to this. So that was 4.5 years ago, and what we did is we went to a trade show to make coffee for people and see if anyone was interested. This machine cost about $3,000 to make, so obviously it's not a commercial product, it was just a try. A lot of the control problems were solved by buying expensive things that already had the control built in. And one of the things we discovered at that show was that coffee was largely pre-scientific. People don't know what's going on. Espresso is pre-scientific. But that if you had control over temperature, pressure, and temperature, but dynamically, so that you could actually vary it 1 second to the next, that could be really handy. And it could be handy in the coffee field, but possibly in any other field that needs water at a certain pressure and temperature and flow rate. And there are other uses in chemistry, for example. So this is what, this is 3 years later. This is the schema of what the hardware actually does. I'll briefly go through it. We've got room temperature water going in, a hardware flow meter, and one of the key things we did, which was a very difficult thing, was to have 2 pumps, a hot water pump and a cold pump. The hot water has a separate circuit, which then runs at 110 centigrade under pressure. Goes through heater, and then we mix them together with some temperature and pressure sensors. And we use the temperature sensor here at the coffee to change the water mixing that's happening here, because the coffee has interaction effects with the water. And what we're really interested in is the temperature here, not the temperature here, right? This is where the coffee is being made. So that's what we're interested in. But we don't know what's good. Should water temperature be stable? Should it go up? Should it go down? We have no idea because we never even had the numbers. So, so the whole project then became, how do I show the information, which at this point is just data. I wouldn't even say it's informative because no one's ever seen it, no one even knows to make of it. This is the traditional approach to user interfaces on devices. You embed it, but you have very limited functionality, but regulatory approval is quite easy. And this is a different school, which is to put a whole lot of functionality into an IoT app thing over here. And so I had to choose which way to go, because this is basically how people make things, right? Either you embed a computer directly into the device, or you make a tablet app like so. But these things are notoriously unreliable. And the purchasing decision for people mentally, people don't even realize, but when they're looking at a home appliance or anything they could buy, they think about this approach: I buy this, and over time it will lose value. I know the features in this, and nothing new will come to this, but it's reliable, and it's not a scary purchase. This is how most things have been bought. They're fixed objects. Whereas this new thing, which is software and you're buying into an ecosystem, is a very weird thing, because it means when you buy a phone, for example, you're not buying the current functionality. You're buying what the phone will become over the next few years. And so you have this investment decision, which is also an emotional decision. It's also a kind of tribal decision. Am I joining this tribe? Whereas you don't have that reaction here. It also makes it much more scary for people to even get into this world. So I didn't like either approach. And I tried to come up with a best of both by having a tablet which is included with the machine, so you don't use your own. And the reason for that is the experience of having to download software, pair with Bluetooth, run it, have the resolution, just to make coffee in the morning is awful, right? Not to mention, as a programmer, it's quite difficult. One of the amazing things about the Android tablet market is the amount of computing power available for very little cost. So this tablet costs $58 US when we buy 1,000 of them. And you just can't get anything in that computing and display power out of a computer if you try and put together something else. One thing I'll also mention here, you can start to see we made the thing very much in the tradition of PCs. This looks a lot like a tower case. And there's a USB power charger here, and people modded the machine immediately, and that was intentional. So here the person's put an external USB power, and I have a photo she just posted. This is a Korean woman. She has a little coffee stirring USB device that she puts in right here. And And here's another example. I was very concerned about future-proofing. So there's two areas where these devices become obsolete. One is the tablet either breaks or becomes too old. So the tablet itself isn't actually physically connected to the machine. So I supply a tablet, but you can also supply your own. This person's used their own wooden stand because they prefer it. Some people get large tablets. One thing I was very surprised about is people had no problem, even no tickle experience, downloading, installing Android-ish, copying the files, running the run make icon program. I thought that would be a major objection. It really wasn't, even for non-technical people, as long as I spelled it out. But this was highly important for people as they were buying into this as an investment, which is this tablet actually was obsolete within a year. And I just ordered Android 8.1 versions of this. It also, from a future-proofing standpoint, meant that the app had to be open source if people were going to buy into this ecology. Otherwise, they knew in 2 years it would be not usable. So very quickly, I'll show you some slides in a second, but I ported it to many other platforms to give people comfort that as Android goes away, becomes something else, because it's open source, it'll keep working. And if we as a company went away, you could still keep using it. So let me talk about some of the GUI problems, because I don't think anyone's written a proper finger-oriented GUI in Android-ish. At least I haven't seen one. This is very much what TK apps look like. They're very small widget, and windowed oriented, whereas tablet apps tend to be modal, full screen with controls that are quite large. And they also invite discovery, so everything's visual. So for example, there's plus and minus buttons on these things. Even though they're not obviously controls, the fact that there are plus and minuses there invites you to touch. I also found, I found Tickle to be essentially fighting me to create this sort of GUI. It took me quite some time to figure out how to create invisible controls, which is essentially what I have to do, because everything that's tappable in TK has to exist. So these have invisible rectangles over everything. And the other thing was that managing the complexity of what should be displayed when was incredibly hairy in code. So what I ended up doing is making an app, and a lot of people have this model, which is basically a little language, and almost everything is in the little language that defines how the interface works. So the skins are just PNGs that I create in Photoshop. I can export them in Photoshop. I create GIF animation, but you can output them as GIFs, as PNGs. And then I open source this so people can make their own skins. Then I have a debug mode, which shows you all the tap zones. And this turns out to be crucial, and the real problem with TK currently is the tap zones, the touch zones are the controls themselves. But people's fingers are really messy. And so making the tap zones as large as possible. So for example, these buttons here are quite small, but I've enlarged the zone as much as I could here. Okay. I also made new kind of widgets, and I've experimented with them, and I'm not happy with what I have now. But people really didn't want to see TK widgets on a tablet. I originally had a slider here, and it really bothered people. So instead, these are just graphics with a widget that originally I had one where I could slide, and that value changed, and people were incredibly confused by that. So the next iteration is plus minus. However, there's a subtlety here that people discover, which is if they hit plus minus, they go in 10 milliliter increments. But if they touch closer here, the increments are much smaller. So that way they can go plus plus to 70 and then go tap, 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 73. So I'd love to get involved with more widgets in Tickle that are fully graphically skinnable. I think that's an important thing if TK is going to be used in tablets, that you can replace all the graphics with what you want. In fact, the general approach of Tickle TK programs is the coder does everything, whereas in traditional tablet apps, you separate the roles of the designer from the programmer so they can work together, which is why I made Photoshop files. So I was really concerned that I would get this all wrong because no one had made a coffee app before. This was a Photoshop mock-up I did with a designer, And he made it very social media-ish, lots of small charts, right, that were basically eye candy, but not actually useful. And then share and social media and plus and minuses. And so this is what he gave me in Photoshop. Then I ended up stripping out the social media band and not coming back to him because I really wanted something that was functional for coffee. This was one of the earlier versions. This was working. These are now just stubs. And I just started showing the application. And then because it was a skin, I started making some fun things. And I thought this would end up being a quite big selling point, that you could make a simple interface that was playful. In the end, no one has cared. What people really want is power, 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 even if it confuses them. Okay, so let me talk a little bit about the skin definition language. So what makes something like this? Because this is potentially something, so everything in here is open sourced. It's a download, but I haven't made documented packages for other people to reuse. So one of the reasons I'm here is to see if anyone is interested in giving me feedback or says that would be really useful, can you make that into something? So essentially the skin language, what it does is it's just tickle commands that are shown at the appropriate time, depending on the context. So the main important command is add a That's Decent Espresso page, called espresso when we're making espresso, and use that PNG. In this case, this is one where it's displayed when the espresso is zoomed at temperature, zoomed, I think at pressure, show this graphic. Okay? So now I've created these two contexts. And then you start adding flesh to the context. So let me look here. This text here says, in these contexts, preheat 1, 2, and 3, or 4, at this XY coordinate, display this text. So my manager automatically hides all the components when you're not in those contexts, and then brings them back when you are. And then the rest is just a normal, all the TK stuff, which is then incredibly powerful. I did a slight modification on that for text, but I want to run a little bit of code in there. So in this case, for example, it's the button that says you should wait because the machine's heating or ready to make espresso. So it looks just like this. Here are the contexts, except I added a new text variable at the end, which has optionally a tickle code that can run. Currently, that's refreshed at a 10 hertz rate. And one of the reasons I came here was to say I don't really like this. I talked to Donald last night, and he said I should move this into the tickle idle loop. So that's something I will try. Bluetooth refreshes at a 10 hertz rate. So that's also why I picked a 10 hertz rate for refreshing the GUI. I don't have data faster than 10 hertz. The more interesting part is buttons. So again, what context? Those are those invisible rectangles. What code to run on when it's tapped. I optionally can either speak to you. So I really focused on sight impaired. So all the important controls are at the edges, so you can grab the edges and just use your thumbs if you know where things are. And then it would say preheat cup. I found the third-party text-to-speech on Android to be excellent in foreign languages. I was really surprised. Google's is terrible, but the third-party ones are great. And then the various things that you can do, and then of course the rectangle itself. Okay? So that's essentially what a skin looks like. And just as an aside, years ago I'd done an anti-spam program with a scripting language, and I found that when the scripting language was super small, people used it. So that was really a focus for me. This is an entire skin. This is the entire code for it. For the one that had the 3 buttons. And you can see there's lots of comments. And it's made so that someone who doesn't even know how to program can load the Photoshop file, modify it, save as, and this code will continue to work. And they can make their own skin. So I wanted a ramp up so that non-programmers could actually make their own skins. And then maybe collaborate with someone who could program. I use BLT for charts. I pushed it pretty hard, so this is kind of an unusual thing to see, a 3-color line. This is showing what the espresso will do. It'll rise in pressure and then decline in pressure. And the charts get extremely complicated because there's a lot going on. So here I've got the pressure goal is dotted, the the actual the reference shot you made in the past is also on that same one. State changes are lines that are off the axis, so they show up as vertical lines, excuse me, to divide things. But even the very complicated chart is not that big, and people can look at that and modify the charts, and you'll see in a few minutes people do. There are some places where I use tickle widgets. Really important that be thumb-sized, and these work nicely. You can't see so well the colors, but these colors match, like so. So there's a direct relationship. These charts, making this so you could drag it, proved to be too difficult. You could tap, 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 but I tried some experiments I didn't like. I have to stay within the user metaphors people are used to with tablets. Using Photoshop turned out to be incredibly helpful because this is the most advanced interface I've done, where you can create individual steps, and you essentially have a kind of scripting language for your coffee, where you're saying the temperature, what sensor to use, whether you're controlling flow or pressure. You have dithered or non-dithered transitions, and then these are essentially exit conditions. These are if greater than or less than. And non-programmers are able to use this, which I was really happy about. And this probably took 4 months of revision. Using Photoshop allowed me to tweak little things like the translucence value of these plus minuses, so that these graphics controlling or telling you what is what were still foreground in the user's eyes, but the plus minuses and the consistency of placement told you these are all things you can touch. And I think these are UE metaphors that aren't used much in TK. One of the things I should mention also is I wanted to make an app that would be equally familiar to an iOS as an Android user. So I didn't want, because most of my customers are actually iPhone people, and they initially object to being on Android. So making the app not feel like it's googly is kind of important, and using this very old metaphor of tabs. Everyone knows how to use those. Okay, here's a skin made by a customer named Damien. It's hideous, but it has many interesting features. I purposely left big chunks of functionality undone so that I would have holes where talented people could come in and make very big progress and get really good feedback. So my interface is tabbed, so it's modal. He has made everything on one page. Okay, so start espresso, all the charts are here, everything's in one place. He's got different programs for shots. Okay, he's made 2 different versions of this, but then he started modifying my charts and adding more information to what's going on. Okay, and really an area I had left undone was looking at the history of espresso. So I save everything with every single coffee to a tickle file, and then I also export it to CSVs. And visualizing the past and how to compare it, I thought was an amazingly hard problem in terms of data visualization. So I just didn't want to touch it. And I had ideas for animation or multiple screens or scrolling. So these are all, I just save every shot in ISO time. And he's got it so you can tap the chart and display charts of previous espressos side by side. I don't know what this is. God shots are shots that you thought were especially good. So he can go through history and then save them, and then when he makes new espressos, compare them. Okay. This has led to many user interface screens, kind of too many, but that's a good problem to have. The whole interface is translated by other customers, and this is funny. This is Swiss German, and it's purposely meant to hurt the brains of German speakers. And we use Google Sheets, and that's worked really quite well because there is version tracking. So one of the big problems with collaboration, I find, is the occasional bad actor. So having every single edit tracked by name and reversible has prevented that problem. But you can see these are just the language codes. These are the strings, and then people just fill them in. Okay. There are challenges in getting things in at the right size. What I haven't done yet, and I don't know if I want to, is auto-sizing the font based on whether it'll fit or not. Because I've seen other apps that do that, and you end up with incredibly small fonts. So this is the French version, which otherwise is in good shape. Updates are done, since every tablet has the source, the update just simply gets a manifest file of SHA signatures for every file, compares them to your SHA, and then downloads just the files that have changed. So the updates are really small, and I love that people who update at different intervals all get their own personal diffs, like a proper version control program. Android Wish has made it possible to run on other platforms. This is also a great sales tool because people go, why would I need a computer to control my coffee machine? And I tell them, well, download the software and see if it would interest you. And it's a free download on whatever OS they're using. This also reassures them that should Android go away, that it'll work in the future. There's the downloads, pretty easy, thiesnespresso.com/download. Security and sandboxing with Android Wish is a pain. Windows antivirus are issues. Right now, Bluetooth support's only on Android, but as soon as I can find a volunteer or do it myself, I'll implement Blues on Linux. So I have a backup, which is Linux tablets. Even if they're more expensive, they're not going away. All right, current issues in 2 minutes. These are problems I'm facing, conversations I'd love to have if you have any insight on them. So this is a hugely big problem for me, which is lots of collaborators and they're working really fast, daily updates. How do I deliver those securely to other people who are less technical without me doing work every day? What kind of generalized extension mechanism should I do? So I can run things inside a safe-tickle box, but then they can't really extend my app. I'm trying to avoid having contributors to the core, because anytime a core feature gets added, it bloats it, adds complexity, and I have to fix other people's bugs because I get yelled at. So for me, loadable modules are the solution there, so that if someone has bugs, I'd like them to be able to boot my app in a safe mode where all the extensions are disabled and it's just my code. And then slowly add them back until suddenly the bug appears. So that's been an issue, and patches. So the strengths of the current Android Wish approach, one is just no one cares that it's Tickle. Even people, I've got quite a few people at Google who have bought this thing, who are Java programmers. And you know, Java, even though it's an open source language, and even if I distributed the app as Java, how many people would actually download the whole Java program, recompile it as an APK, and reinstall it? Virtually none. Whereas having the source on the actual tablet and be able to change one line, or just plug it into USB as a drive and drag an extension, rerun, and it runs, means that there's a very gentle Tickle onboarding for people. The skins also, because they can just copy a line, see, oh, there's a variable for dynamic temperature, put that in, see if it works, boom. And the fact that the app doesn't crash silently, it crashes with a big loud Tickle error, which then helps you fix it. Okay? And the desktop environment is a really big deal because embedded programming is really slow and tedious. So here are big next steps. One is we're currently Bluetooth communication. One thing I didn't mention. On the back of the machine is a little 8-pin socket, and it just uses the Raspberry Pi standard for Bluetooth. And the reason is the other thing that will go obsolete is Bluetooth. Right? We're on Bluetooth 5 now. There'll be other communication mechanisms. And in fact, the company that makes our Bluetooth module went bankrupt. But they were open source, so we made our own PCB version of their thing. So the intent with the hardware is you can change the tablet and you can change the communications mechanism. And you can just buy something that works with the Raspberry Pi standard. What I'd like to do is a REST proxy that hides Bluetooth, because Bluetooth is not going to be always what we use. We'll have a serial port interface and other things. So that you could actually write JavaScript apps that then talk to a cloud server that then proxies to your Espresso machine and does things. I would like to save things into the cloud because the whole point of this was to discover what's possible. But data privacy is a huge concern. And so I don't even know if I'm going to do it. App stores allowing an ecology where people might be able to make money is a real question, and also that's a lot of work to create. Some things like profiles, but bad actors have always been a huge problem for my other projects. Eventually they appear and they destroy everything. So I'm very reluctant to open up my machine to the internet because it works now. And once I put it on the internet, it'd be harder. Being able to manage lots of machines, I like to think of this as essentially a server blade. So SNMP or other mechanisms would be a possibility. So if you own a cafe, you could see all your cafes with a normal server management tool. I can't sell people iOS tablets, but it is part of the religious wars. And it'd be nice if we had iOS support. Maybe we will eventually. Linux tablets, Android tablets are not especially part of Google's future. They made it pretty clear. So that's something, that's why I'm so happy to see so much on Android Wish, because that's everything I need for my app to run, and I can now run it on other devices. So that's quite promising. That's the whole presentation. That's my email address and the download. Thanks.